deals with polyatomic ions. So the sum of the oxidation numbers in polyatomic ions equals the charge. So, for example, if we have SO4 2-, we have a 2- charge. So we have one sulfur, not quite sure what that oxidation state is, plus 4 times the oxidation state of oxygen, which is going to be -2, has to equal -2. So here, if we do our algebra, our x is going to be equal to -2 plus 8, or x is going to equal +6. So here our oxidation state, or our oxidation number of sulfur in SO4 2- is going to be +6, and the sum of all these oxidation numbers of the atoms in polyatomic ions has to equal the charge. Okay? Rule number 5 deals with oxygen. So the oxidation number of oxygen is -2, with the exception of peroxides in peroxides O2 2- has an oxidation state of -1. So the oxidation state of oxygen is -1 in peroxides. The common example for this is H2O2, which is hydrogen peroxide. In compounds involving hydrogen, which we have 2 of in this case, our oxidation state is going to be +1, plus 2 times -1 is going to equal 0. So here, these oxygens are in a rare case where they have an oxidation state of -1. Rule number 6 is the oxidation number of hydrogen is +1, except when it is combined with a metal. So in all cases, with the exception of when it's combined with a metal, we have hydrogen having an oxidation number of +1. An example of the exception would be NaH, where sodium has an oxidation state of +1, and hydrogen has an oxidation state of -1. The last rule that we're going to use is that the oxidation number of fluorine compounds is always -1. So an example of this complex would be xenon OF4. So in our particular complex right here, we would want to determine what the oxidation number of xenon would be. In this case, we have 1 times the oxidation number of xenon plus 1 times the oxidation number of oxygen, which would be -2, plus 4 times the oxidation number of fluorine, which is -1. This has to sum up to equal 0. So our oxidation state of xenon is going to be 0 plus 2 plus 4, or our xenon oxidation state is going to be 6. So these are some general guidelines for going through and trying to determine what the oxidation states are for various atoms in particular compounds or ions. And again, we're going to use these to effectively analyze what happens in redox reactions. So in the next video, we'll go over some examples where we determine the oxidation states of all the various atoms in particular complexes or ions.